Okay, so let's go and start implementing some shadow maps. I'm going to go a little bit fast as I always do during these classes. That means that the code, the structure won't be perfect. You always have chances to improve my design, so don't hesitate if you think that something should be in another place, or you want to change the name of a variable, or you want to use a struct. It's common, as I said. I'm trying just to show you the algorithm itself. It's up to you to try to put this inside the code in a way that is going to work well for the rest, because we're going to keep adding more algorithms. So it's always nice that you spend some time trying to structure the code. But anyway, my goal today is just implement the shadow map for one of the kind of lights, in this case for the spotlight. And for the directional light, you will have to code it yourself. We are not going to code shadow maps for the point lights, obviously, because it takes a lot of time. And because I have some time, I would love to show you also other tools that you may want to use to when during the development process that could be helpful for you. Okay, so without further ado, let's go to Visual Studio. We're going to be following these slides from the other day. There's a lot of snippets of code that are super useful for you. So, oops, sorry. I don't know what's going on. I cannot change the slide. 1 second. Presentation slideshow. Okay, so you can see there's many blocks of code that we can use, and they are commented and explained. But all these blocks of code I'm giving you, they are not, I mean, they are just isolated from the whole engine. So you have to think about what's the best place to put these blocks. Okay, there are many errors that you can do if you don't take care of, you don't read this code and understand what it's doing. So don't go with the autopilot copying and pasting code to the engine, because that's very likely that's going to produce some errors. Okay, so 1 second. I don't know why it's not allowing me to switch slides. It's just scrolling instead of passing to the next one as usual. That's weird. Well, anyway, okay. So first of all, as we said, we will have to restructure a little bit our render scene. So here, when we render a scene, we just start rendering. Like you can see, boom, we start. We don't do any prior steps. We don't do anything. I could make this function longer, but I like always that my functions, as much as possible, they only take one screen of my computer. So if a function is very long, I prefer to break it in smaller functions. So in this case, I want to separate what it's the first steps to when we start rendering. So let's call this function render frame. This is going to be the one that renders. So if we have to do something prior to that, we can do it in a different function. Okay, so this render frame obviously doesn't exist on the engine. So let's go into put it here, for instance. We are in the renderer all the time, obviously, because the renderer is the important class for this kind of things. And here we can call the render framer and pass it. So we have to do something. We have at least a way to separate it in different steps. Okay, cool. Let's test that it works well. Always when you do minor test, so you don't break anything, everything works. This is what we have from the other day. We have the directional light, we have a spotlight, and we have by the way, this is spotlight, it's very big. I have the impression that I'm passing the wrong angle. Let me see something. Here it says that the cone angle is 39 degrees, the maximum cone angle. So if we have like these are 45 degrees. So in our engine we say 39, so it should be something more like this. This is the angle that we should be having, something like this. Okay, so something like almost 45, but a little bit less. But if I go here and look down, it's 45. Yeah, I would say. Yeah, okay. I was worried that we were having like half the angle. Sometimes it's very common that you specify the full angle, but you're passing half of angle, or the opposite. You specify half angle and you're passing the full angle, or something like that. But no, it looks nice. Okay. So next step is we're going to make a function that is going to be in charge of generating the shadow maps. Okay. Generate shadow maps. And I can pass the camera. Yes, let's pass the camera. I don't know if I'm enabling the camera ever. Yeah, I should have enabled the camera somewhere. So like here, I usually do this, enable. I don't know why I didn't do it on this function. But probably I did it in the outside application probably when I'm doing the render. Yeah, I was doing it here. Yeah, I think this is an error. Enabling the camera should be part of the rendering process because you're passing the camera, so the inner engine should know that the camera has to be enabled when you're going to render. That's a little bit cleaner. So I will change that on the framework on the repo because I think it doesn't make sense. So generate shadow maps. We don't have that function, obviously. So let's go here. I don't know, here. Void generate shadow maps. What are we going to pass to this function? I don't know. I mean, the scene is here, and the camera. If we can also have like the camera, if the camera is enabled here, we can have it. But I'm going to pass the camera. But I won't pass it until I need it. Okay. So for now, I have the function here. I don't have the body of this function, so let's build the body for this function, where I want to leave first all the render calls and everything for rendering and do the shadows at the bottom so they don't stay in the middle. Okay. Okay, so every time we're going to render the scene, first we're going to generate the shadow maps and then we're going to render the frame. Okay. Then the shadow maps function here, we have to render the scene from every point of view of every light and the full scene. So we're going to see that maybe we need to tweak a little bit some of the functions that we already have because we want to reuse them. I mean, this render function here, it does many things that we may want to, like it's doing this, for instance, is rendering every single node, which is handful. I mean, it's good for us that it renders every single node. The only problem maybe is that this function render node here, it does it calls this render mesh with material or render mesh with light, and we don't want to render with light or with material. We want to render it super simple because it's a shadow map. So well, maybe we will have to change some of the functions here. We will see. So first of all, when you want to generate shadow maps, you're going to generate shadow maps for every light. So I'm going to iterate through every light. Do I have the lights here for iterating? Remember that we separated lights in this array called lights that we are, no, here not, sorry, on the render scene. Remember that before we render the scene, we call it setup a scene, which by the way, we may also generate the shadow maps inside here. I don't think it's so crazy. So first we iterate through everything and we generate shadow maps. Okay, so we call setup scene, which is going to search for all the lights on the scene and the prefabs, and here you can do all the render calls things I recommended you. And then we have the generate shadow maps here. And because we have all the lights, it's easy for us to iterate through the lights. If you want to iterate, because lights it's a STD vector, you can do the classical E equals 0, blah, 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 light size. But because it's an STD container, it comes with a nice function, which is you can type this auto lights. Okay, this is a modern C++ feature that allows you when you have a container. I know this works with STD. I don't know if it works with other kinds of containers, but here you can walk through all the elements on a STD container very easily. So then we have the variable light, which will contain a pointer to every light. So if this light doesn't cast shadows, then nothing to do because this light is not important for us. So forget it. If it casts shadows, then we have to do the process of computing. So where are we going to store the shadow maps? There are many options. I mean, we can have an array of shadow maps in the renderer because I don't like to pollute the data structures with rendering stuff. So we already have a light class here. And this light class doesn't store anything related to shadows, okay? So, by the way, this light data, I'm going to remove it because we're not going to use it. And I think it's going to be better if we don't have all this strange code that you don't understand. I removed the other day from the framework. I forgot to remove it from my copy. So this out, okay. In case you are wondering why do I have that structure there, it's an optimization. I did it because I first did all the course code on my own version of the engine, and it was more optimized to send data to the shader. There are tricks that you can use, but I don't want to use these tricks with you because maybe you can get lost on this kind of things because they are a little bit tricky. Like you have to align things in memory and stuff like that. That could be a little bit annoying. So cast shadows, doesn't cast shadows, nothing to do. We can also check here. I'm not going to do it now, but in case you like optimizations, check if light inside camera. Okay, it would be nice to do this because if this light is not inside the camera, there is no reason for me to update the shadow maps. Okay, and it saves a lot of time, but I leave that up to you, so you can explore a little bit how to do this. It doesn't have to be perfect, but as long as it just saves you from computing shadow maps from some lights, it would be nice. Okay, so next thing, we need to have a texture where we're going to store the shadow. So let's build a texture, but it's going to be a depth texture. Remember that we're going to store the shadow map as a depth texture only. So instead of creating a depth texture and then create an FBO to render to that texture, we're going to construct an FBO. So I'm going to go to the light. I'm going to put the rendering things here, okay? As I say, this is not the best solution. In my implementation of the engine, I store all the shadow maps inside the renderer. I have an array of 16 shadow maps, and I just reuse it constantly. I think it's more optimal and it's more clean, but if you want it to be more readable, maybe here is the most approachable. So here I'm going to say that we have an FBO, okay, shadow map FBO, okay, and we're going to use this shadow map FBO, and maybe also we can have a texture shadow map. Okay, remember that when we make the shadow maps, we are going to need to reconstruct every wall position projected to the shadow space, and for doing that we need to have the view projection of the shadow map. So next step is to have a shadow view project. I don't know if I can list like this on the slides, but this way I'm always sure that I have all the information I need. Okay, so next step is build or construct or initialize these things. So if this light doesn't, sorry, by the way, I construct a lot of variables, but I didn't initialize them. Bad idea. So always go to the constructors and put them to null. So we are sure, damn it. We are sure that we don't get any problem when we check if they are have a value or not. So here we can say, do we have a shadow FBO? If we don't have it, it's time to build it. Okay. So in this case, I'm going to say it's a new effects FBO. Okay. This only constructs the FBO, doesn't allocate memory for the textures. So if we want allocate memory for the textures, you can have to here to say create or something like that. It's not telling me the enter is sent because I did a hack. Yeah. You can see that when I created this, the GFX FBO here, my frame buffer object, I didn't include anything, and it didn't ask me to do anything. Like you have to include. I should always be including these special classes. So you may think, oh, you already included, but I didn't include it. You can see I only include this one and this scene. And is this scene including the FBO? No. So actually including math, camera. So there's something strange going on. Why it allowed me to construct the FBO if I didn't include it? This is because, well, there's many reasons, because somebody is probably doing forward declaration saying in some places of the inclusion, somebody saying the FBO is a class that exists, but it's not implementing it. So I would recommend you always, when you do this, you go here and include in this case, is in the GFX folder, this one over here, it's the FBO. But because we are in another folder, we are in pipeline folder, we are in in light, then we have to go out one folder, then we have to go to the GFX, and here we have the FBO. Okay, So now we have the FBO class here that we can use from here. And don't worry about the texture because FBO already includes the texture class as far as I know. So if I go back here and I say, okay, light, shadow map, FBO, and I put here, if everything goes well, now it recommends me. So if the Visual Studio is not, the IntelliSense is not working, be careful because it means that the compiler is checking the types and saying, I don't understand what's going on. So there's here this set def only function where you can specify some size. I'm going to go with 1024 by 1024. And it's going to create only a depth texture, not the color texture. And then you can use it when you render to this FBO. It's going to scrap the color and only use the depth. Okay. And because we wanted to have the shadow map separated in another place, I'm going to go here and say that the shadow map, the light shadow map is going to be equal to the depth map that is here. So here we have the depth texture, sorry. So, okay, we have created already the shadow map. We can use it. Keep in mind that for every light, we're going to be creating shadow maps, textures, okay? And these textures could be big. In our example, we're not going to construct and remove lights constantly, as far as I know. But the problem is that if I keep running this engine and I construct lights and remove lights, if I'm not destroying this FBO and this shadow map, it's very likely that I'm going to run out of memory. This is a memory leak right now. So on the structure of my light, which I don't have one, So it will be important always, as a good measure, always to have the structure. And in this case, because I have these variables that are new, say, hey, if by any reason you destroy this, if we have an FBO, if we have an FBO in this light, I don't know why it's complaining. He doesn't like this. Why? Well, we will see when it crashes. It's saying light entity. Yeah. Sorry. Yeah. Sorry. Because I forgot to put the namespace. Because I have a namespace. Okay. So if this light has a shadow map, remove it. I don't think I have to remove also the texture because the texture is held by the shadow map FX and it's going to delete by itself. Let me see if I can go to the shadow map, the FBO, the structure. But as far as I understand, on the structure of the FBO, if going to free the textures, that includes also the depth texture. So yeah. So here you can see that it's going to delete the depth texture. So I don't need to do the delete of the texture. Indeed, I don't know. I shouldn't, because if I do it, it will crash because I'm deleting twice the same object. The rest I don't need. The matrix is an attribute that is going to be destroyed automatically. Okay, so we have no memory leaks now. We have an FBO. I can render the shadow map there. So it's time to start rendering to the FBO. So when you want to render inside the texture, remember you enable it. Sorry, bind. And from now on, everything we render is going to be inside this texture, okay? And when you finish, you unbind it. Okay, so now here is the part where we have to render the whole scene, okay? There are different approaches I can follow here. If I wanted to do a fast test, what I can do here is I can do something like render frame. Remember that render frame, if we have here the scene and the camera, by the way, I need to compute the camera there. Okay, so the camera. I'm going to create a local camera. It's okay if this camera gets created and destroyed every frame. I mean, I can construct it outside. Maybe if I have many lights, I reuse the same camera. I'm not going to store the camera because, I mean, it's not like we're going to use the camera. We're only going to use the view projection matrix, and I already copied that at the end of the frame. So here, when I have rendered everything, I can go to the light and say, hey, your shadow map view projection is equal to the camera view projection. Okay, and that's it. So I can reuse. I'm going to clone it. I'm going to copy it here, so it's okay. So the only thing missing is I need to position the camera and set up the perspective or whatever in the right way. Because I'm going to do this using, I'm going to compute it only for the spotlights. For now, I'm going to put here if the light type is different from a light type spot, so it's not a spotlight, continue. For now I don't want to compute for directionals. It's up to you to do that. Okay, so we are sure this is a spotlight. So here it's time to compute the camera. So we have a camera. First, when you have a camera, you have to position the camera in the right spot. So what's the right spot of the camera? The camera has to be exactly where the light is, and we know where the light is because here, if we go to the light, there is a root node, and inside this root node there's a model matrix, and this model matrix we can get the translation. Okay, and I'm going to put this in a outside, something like this here, vec3 pos. By the way, you will see that in the engine sometimes I put vec3 and sometimes I put vector3. It's the same. Okay, sorry, vector3 f. It's exactly the same, vector 3 and vec3. So I have different places to type defs to match. But if you see in the slides in any moment something like says vector 3 and it's not like this, be careful because vector 3 is without type. It doesn't know if it's for floats, integers, or what. You have to put F to say it's for floats. You can see here there's different types. So maybe in the slides there's some places where I forgot to put the F. If that's the case, always remember to put it. Or if you put vec3, by default it's going to assume it's a vector 3 because vec3 here, you go to definition, it's a type def. It says if you find vector 3, put vector 3 f. Okay. In case you're wondering, here you can see how this works. In C++, you can use templates. If you never have used templates, it's when you have a class, but you want to that class has a type that you want to have versions of the same class with different types. And with vector 3, this is kind of common because you may have vector 3 of floats, vector 3 of integers, or vector 3 of doubles. So you can abstract this class and you say this class is going to have a type called t, okay? And this t is going to be generic. You can put whatever you want to. So inside the class, you can put the t wherever you will put the type. So here I will put float, and all these t's. So you just put t. Okay, so now this is not a class, it's a template. And when you want to instantiate one version of this, you can do this. You say, hey, I want to construct a vector 2 of type floats. And this is, in this case, it's a type def. It's going to be vector 2f. So when he finds this, he's going to go to this class, replace the t with floats, and compile it as a class. That's nice because, well, it saves you time to have to code the same class again. And you can do many nice tricks. So for my vector 3 and my vector 2, 3, and 4, I have templates because there's many cases where I want to use doubles or integers or something like that. I thought it was nice to have it. So I added this feature in the last year, so in the new version of the engine. So I may have problems in the slides where I didn't realize about this. Okay, so we have the pos, and we have to look at pos. Next thing, when you want to say the camera, what is the camera? You have to say where is the camera and what is pointed at. So you need a place where the camera is pointing the direction. Okay, so because for the camera, sorry, for the light, we have where is the light. Okay, we have the pos, but the orientation of the light comes from the matrix. Okay, so I have to go to the let's say I have a front vector. So I'm going to go to the matrix, which is here again. And there is a function called rotate vector here. By the way, I really did this, the rotate vector for the spotlight. Here, you can remember that I did it here. So I'm going to reuse the same code. When I was doing the spotlight, I already needed the front vector. Okay, so vec3 front is equal to this. Okay, so, and I don't have this. So now I have where is the light and the direction where it's pointed at. But the camera look at don't need the direction, needs the point where it's looking at. So it doesn't need this vector, it needs this position. So that means it's pos plus front. Okay, and finally always the app vectors is usually 0, 1, 0. Because remember that when you specify camera, you have to specify the app vector, okay? In in 99% of the time, the up vector is 0, 1, 0, so everything will work fine. But there's one case where the up vector shouldn't be 1, 0, 1, which is if the light is going perfectly straight down. Okay, if we had this and we put that the up vector is this, because these two vectors are opposite, remember that when we have the up vector, what we do is we do the cross product between the front and the up to get the right vector. And with the right vector, we do the cross product between the right vector and the front to get the top vector, which is this one. And then we have three vectors that have a 90 degrees angle between them. And with these three vectors, we construct the system of the camera, the orthographic system. The problem is that if these two vectors are opposite, then when you do the cross product between this one and this one, it's going to give you a vector 0. And from here, all the computations are wrong, because when you do the cross product with a vector 0 to get the other one, it's going to be 0 again. So you're trying to construct a coordinate system with 0, 0 on some of the axes are 0. And the result is going to be a system that doesn't, I mean, when you try to project any vertex, it's going to disappear. So when you have a camera that points totally like a light vertically down, it's always nice to have a control here, like something like if front is 0, 0, minus 0, minus 1, 0, something like that. And then as a vector up, you have to use a different one. Sorry, not here. So you can have something like this. We are not going to need it because we don't have a vertical light, but it's good to have a control over those situations. So something like this is the up vector. And if the cross product between the front and the up is 0, then change the up to 1, 0, 0, for instance, something like that. But anyway, for now, we have a camera set up. We need also to specify this camera's perspective for projection. Remember that there's two ways to render the scenes. We can render, let me show you this in a better application. So, 1 second. So when we have this editor here, remember that there's two kinds of ways to render things. This is a perspective rendering, obviously. I'm going to put several people here. And so the farther it is from the camera, the smaller it is because there's perspective. But always remember that we can render in orthographic, okay? In orthographic, no matter how far things are, they have the same size. Look at how it's nice to, it's common to see this and you feel that this one is bigger than this one because it's supposed to be, if it's far away, it shouldn't be, should be smaller. But and our eyes perceive it like this has to be bigger. So to be farther away, have the same size because it has exactly the same size. If you measure from here to here, it has exactly the same as here. Okay, it's just an eye illusion. But when you are rendering in orthography, remember that you can define how much is the frustum size. So you can render more size or less size of the frustum, okay? So anyway, we are going to work on a perspective camera because we're going to go with the spotlights, and the spotlights are perspective. But we can still control, always remember we can control the focal length, the FOP. So we can control this, and this is, we're going to control it to adjust it so it measures exactly the same as the one in the cone of the light. Okay, so let's go back to the code and say, okay, this camera, we know it's a spotlight, and because it's a spotlight, we're going to have a set perspective. So 4 parameters we need always. First, the FOP. We need the FOP in radian, no, in degrees. Yeah, the FOP is in degrees. And from this light. And that's easy, because if you remember, in the light we have the cone info, and the cone info, I never know which one is the big one and the small one. I think it's min max, if I recall correctly. So the second value is the max angle. So the max angle is the one we need to put the camera as a FOB. And then the aspect ratio, because our shadow map is 1024 by 1024, the aspect ratio is 1. We can control it here and put something like, I don't know, width divided by height, but for now I'm just going with 1 because I know it's going to be 1. And near and far planes. Sorry. We have near distance and max distance on the light, so maybe it would be nice to take advantage of that. Near distance and max distance. Oh, sorry for the light. Okay, so now we have a camera that if we render from this position of the camera, we're going to see what the light of the car should be seen, the light that is in front of the car. Maybe it would be nice to check to see that it's working well. And one way to test this is working well is instead of rendering the scene to the FBO, we render to the screen. So I'm going to comment this line here. I'm going to comment also this line over here. Okay. Now I'm going to render the frame. I'm going to pass the camera. This function is waiting a camera that it's a pointer. So I'm going to have to take the pointer here. So I can render this, and because I'm not storing it inside the texture, it won't be. So it will be visible on the screen. The only problem is because then on the render scene function here, I'm going to call render frame again. Is going to override on top of it. So I'm going to comment this one. So let's see what we see. If everything will go well if we see the scene from the point of view of the car. Okay, interesting. What we see is from the point of view of the light, but on the opposite direction. I have a problem with the front vectors in the engine. I have to clean up a little bit because for the spotlight we are using the 001 as the front vector, but for the camera it has to be the 00-1. Okay, because you can see it's the opposite. Instead of pointing in front of the car, it's pointing from the top front of the car to the back. Okay, so look, we realize about this error very soon. If we didn't have done this, we will have missed it. So here, this has to be -1. Okay, we have to look in the front side of the car. And there we have it. We are looking at the scene. And it's nice because if I go to the spotlight and I touch the cone end, you can see that we are matching the fob of the spotlight. Okay, good. That's a good signal. We are on the right track. And obviously, if I move the light, it's going to move with the light. Okay, good. So now we render this to this texture. I'm going to go here and put this back again. So if everything goes well, we have a shadow map. Okay, if I render this again, we won't see anything. We have the shadow map stored in memory, but we are not able to see it. Okay, cool. Then it would be nice to see the shadow map. Okay, it would be super useful if we could see the shadow map somehow, but obviously we don't have a function here to show shadow map. I added you this function to show the textures, but and if I try to search for the shadow map, it probably is here. This is the shadow map, okay? But it's interesting that you can see that we don't see anything on the shadow map. It's all white. And this is for the thing I told you the other day. There is a limitation when you work with depth textures, and depth textures are not linear. Because they are not linear, when you try to visualize them, you probably are going to see all white. The information is here, but the way it's mapped is not like from far away is 1, close is 0, and in the middle is 0.5. It's more like almost all the grays are in the very, very, very close area, and the rest is almost white. I can show you that if I go to the shadow map here and I put it very, very, very close to something, like super close to the floor. Let me go like this, super close to the floor. Now it has areas that are super close, and because they are so close to the camera, you can see if I go to the textures, if I'm lucky, and it's still hard to see. Let me see if I'm modifying this a little bit. You can see it. Yes, you can see here. Yeah. You can see here something when I move a little bit the spotlight. Okay, so how can we see it in something that looks better than doing these hacks? I would recommend you to render the shadow map on the screen. Okay, so let's do that. What I'm going to do now is, while I'm rendering the scene here, after rendering the scene, maybe I want to render some debug info. It could be useful to have some rendering debug info. In this case, maybe it would be nice to have a parameter here. Let's call it no, sorry, not in the lights, on the renderer. What is the render.h here? Something here, say something like will show shadow maps. Okay, so this function is by default is going to be false, but obviously we want to have a parameter to control it. So Okay, so now we can toggle this show shadow maps. We're going to use it to do the book. So let's go here and say, oops, if show shadow maps. Okay, then what we should do? Maybe it would be nice to have a function here to do it. The book shadow maps. Otherwise, it's going to be a little bit ugly to put all the code of rendering the shadow maps here. So I'm going to go here because this is more the back. Okay, and this function, let's put it right before the show UI because it's not an important function. So here, yep. Okay, so what it's going to do is obviously it's going to iterate through all the lights. Okay, so let's go with the lights. If the light doesn't have a shadow map texture, then doesn't have to do anything. Continue. And if it does, we are going to render it because only we have one shadow map now. We should be able to see it. So how we render one texture onto the screen? This is a common problem that people don't realize, that you're used to render things on 3D space, but you're not used to render things in 2D space. So first, we always disable the depth test, because if you are rendering in 2D space, you don't want to use the depth buffer, otherwise the buffer could be problematic. Also, we disable the blending because we don't want to blend anything, and we want to render one texture. Okay, in this case, which texture it is this light shadow map. So what we have to do is create a mesh that is the whole screen, create a shader, pass the render that mesh with that shader, and pass the texture to the shader. If you don't want to do that, I give you for free this function called to viewport. Okay, it does that. And if you can see it, what it does is first it gets a quad mesh, then it gets, if you don't specify any shader, it's going to get a shader called the screen. It's going to pass the own texture to the shader as the name uTexture, and then it's going to emit a render, and that's it. Okay, so you can see this is very useful, the to viewport. It constructs, it renders to the full viewport a texture. Okay, and with this it should work. Let's test now what happens. The only problem is we're going to render it as a color texture, and this is not a color texture, it's a depth texture. So if we try to do this, we're going to face the same problem again, which is if you go here and show shadow map, you can see we have the grid, by the way. I hate the grid sometimes because I want to remove the grid and it's in the middle. 1 second, I'm going to remove the grid for now because the grid is more for when you want to the book, but that's not the case now. Okay, I'm here. What? Sorry. Yeah, and I'm going to go here, show shadow map. And as I said, we don't see much. If I go to the spotlight, as I was saying before, and start moving around, maybe there's a moment where you can see, like here, something information, like there's information on the shadow map, but we cannot read it visually. Okay, so as I said, it's not linear. Can we linearize the shadow map? The truth is yes. I gave you a function to linearize the shadow map because I know that you were going to need it sooner or later. So instead of here passing just no shader, I'm going to pass here a shader, and this shader, by the way, is called GFX shader get default shader, I think I call it, and it's called depth, I think I call it. Let's check out this function. This function, I create some shaders that are always useful, and there's one here called depth, I think that's linear depth. Okay, so let's go with that one. Okay, and this shader, by the way, we have to enable it, obviously, because we're going to need to use it. And I'm going to pass to this shader. I need to pass to this shader the nearest and the farthest for the camera, because to linearize it, it needs to know what was the near and the far plane. Okay, I don't know the name of the variables because I have to pass here the near and the far from the camera. So let's go to the shader again, to this linear depth, and here we search for the name of, and here it is, u camera near far. Okay, cool. So there's a variable called u near camera far, which is a vector 2. And here we need a vector 2 that contains the near and the far. Where do I get the near and the far? Well, it's, remember that we use from the light the near distance, and for the light the far distance when we max distance. Sorry, not max distance. Yep. So let's try again to see if we are more lucky now. And we render everything. We go view, no, sorry, view, no, projects, show shadow map, and boom, we have something that looks like a shadow map. Okay, and you can see now that if I move this spotlight, I take the position, it matches, and it matches. Yoo-hoo. Good. Okay. I think now's a good time to show you a nice feature that I didn't have time to show you the other class. Something that's super useful when you do rendering, which is that because our rendering pipeline is getting more and more complex, it would be nice to be able to debug it. Okay, like debug every single step of the GPU. But we cannot do that from the Visual Studio because Visual Studio only compiles some C++ code, and then when you're executing, you can debug the C++ code, but not the GPU code. Okay. So there's an application called Insight. Let me show it to you. Okay, I have this window here. I'm going to go with quick launch here. Yeah, and then you get this panel, and it says specify to me one application that you want to run that is going to have some access to the GPU. I have to execute, by the way, probably in admin mode. Sorry. So I'm running it in admin mode because this application will need to access like capture another application, and that only can be done if you are in admin mode. So what is this application? I'm going to search for this application. 1 second. So the application is in the folder for the course. I'm searching for it. GTR framework. Yes, this one over here. Yeah. Okay, specify the exe of this application. Okay, and now if I press launch and the frame debugger, because there's different options. I was playing the other day with different options. What we want is frame debugger. So you say I want to launch it. It says which API support: OpenGL, obviously, Vulkan, DirectX 11 and 12. So launch it. You wait a second, and it's allowing me to give you access to the application. The application is launching. And you can see that suddenly there's this windows in top of my application. Like, hey, I didn't code this. It's okay. It means that the capture is working. It's not saying that because I'm using some version of Windows 10, blah, 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 something else is not working. It's okay. I don't care. But the more important thing is I have another window here now. Okay. And this window can tell me information about what's going on inside the GPU during this execution. Okay. But for me, the more important thing now is this button here, capture for live analysis. If I press this button now, it says, are you sure? Yes, because it can crash the system. And boom, I have this. Okay, and this is super cool. I'm going to show you, maybe if I can put this side by side. I can move this around, and it's going to show me what's going on the GPU in real time. Okay, the things that appear red, you can see them here on your viewport, or you can see here. I'm going to use this one better. You can see that when I move the time, this is the time it takes to make one frame. It was like 5 milliseconds, like you can see, from 0 to 55 milliseconds, no, nanoseconds, I think, or microseconds. And when I move this time, you can see any render call that has been done. For instance, because I'm using the multi-pass light, sometimes you can see the every pass. But also interesting to see also how the shadow map is being generated here. You can see how it's generating the shadow map first. And also you can see that it's showing me the color buffer, but in this case of the shadow map, I may want to see the depth buffer. If I click here, I can see the depth buffer, how it's being built step by step. Okay. Okay, and nice thing, another thing is that you can see all the GPU calls that are being done in any moment. Okay, and also here you can see for every GPU call which textures were binded to the GPU. So here, for instance, when I render in one object here, it says you were using this texture and this texture, blah blah blah. I can see even information about the shader, a lot of things. So the buffers, all the meshes that were used. And another thing that would be nice. The problem is that when you see this, there is a lot of like calls here, and it's hard to read what's going on when some calls are starting and when some calls are ending, and what's every call for. It would be nice if we could tag them, like to say, hey, this one here it's the shadow map. This one here, it's for the final render or something like that. So you can also do that. I'm going to show you how you can do it. So I'm going to terminate this one. Terminate, it's going to kill the application. I'm going to hide this. So I don't know, let me see 1 second, one thing. If I'm calling, I thought I was calling one function, but now I'm not sure. No, I'm not calling it. Ah, yes, I'm calling it here, frame. Okay, but this is the full frame. Anyway, so there's a function I give you. It's called GFX star GPU label, like you can see it here. It calls an OpenGL function where you pass a string, and it's going to store that string on the GPU. So if there's any debugger of the GPU, it's going to show you where that label enters. So in this case, when we're doing the shadow maps, let's go to the function that did the shadow map. Okay, generate shadow maps, and I'm going to say, hey, can you label here, this is shadow maps? And when you finish this label, you have to say it here. It's called end GPU label. Okay, so I can compile again. Everything works well. My application, everything. I close this. I go to end site, and I'm going to connect again to my application, launch again. It's going to launch my application, and then I have to wait until it connects from the other side. It's connected now, so I capture one frame. I capture one frame, and you can see now here I have frame. Frame is the global one. This is in my code, frame, by the way, this name on the core here. When you start rendering, I put frame, and when I finish the render, I finish this level. But inside frame, I also have a new one called Shadowmaps. Okay, this is so you can tag all the moments on the time with labels as much as you want to, so you can have more fine grain. So at the end, it's easy for you to spot in which moment you are doing. And here also something nice about having this is that I can know the shadow maps how much time takes. So currently on my engine to render the shadow maps takes 0.27 milliseconds. So okay, I have measures. I have measures to know the full frame and these shadow maps. Okay, so nice. Another interesting thing, maybe here, let me show you. Every single step when I move this mouse is one draw call. Okay. So let's go when we are rendering, I don't know, the house. So here I'm rendering the house, but if I go to the next draw call, you see it's also rendering the house. You can see this rendering the house like 3 times. It looks like 1, 2, 3. And then if you think about it, it's true. I did an error because in my current code, when I generate the shadow maps, I'm running the same function I was running for rendering the lights. So remember here, I'm calling the function render frame, but render frame inside is can render node, and render node inside is can render a mesh with light. And here we are iterating through every light, which is wrong because for the shadow map, I don't have to render the house 3 times for every light. I only care about the set buffer, so with one will be perfect. So I shouldn't be using this function, this kind of render mesh with material light for this. You can clean up the code in many ways. Here you have the render mode function. So I don't know, maybe we can have another mode. So here, let's call it, so this is flat. Textured. I'm going to say I'm going to add more render modes over textured, and this texture mode is going to render with. But we want to have one that doesn't, because I mean we can use this one, the one we were using that uses textures, but this has also sending the emissive and the color and the albedo, and we don't care about those things because these are not related to the depth. So I'm going to make a new one, and we're going to call it flat. And this is going to be the simplest version of the render with mesh with material. So I'm going to define this function here, maybe flat, and this one here is going to be almost exactly like this one, very, very similar, but I'm going to cut all the crap that is not related to the shape of the object. So anything that is related to the light or the color, I don't care. So for the shadow map, I'm going to only care, let's go line by line, for instance, Do we care about white texture, albedo? No, we don't care about texture. Out, all out. We care about the alpha. Indeed, if the object has alpha, maybe I don't want to render it, because remember that for the shadow maps, should glasses have shadows? It doesn't make any sense. So what I'm going to say is, hey, this object has transparency. Then, fuck it. I don't want it. I don't want to render this object because it has transparency. Okay? So no blending. Is it two-sided? Yes, it could be important because maybe we want to render something from the other side. And I'm going to use a shader that doesn't use any texture. So let's call it flat. Okay, and here we go. The model, yes. The time, we don't use the time. Color, messy, blah, blah, blah. All out. Alpha cut out. Maybe we should be passing the texture to the transparency, but for now, I don't care. And well, the polygon mode, I don't care because this is why I wanted to render it in wireframe, but doesn't make any sense. That's it. If everything goes well, this function is quite tiny, as you can see. Okay, I'm going to remove almost everything. And you can see that this function should be super small. Okay, so we have this render flat. It's super simple. It just renders with a flat shader, which, by the way, the flat shader, I think I have it here. I think I usually have always a flat shader. So yes, I have a flat shader that calls this flat FS. And if you go to flat FS, you see, well, it expects a color, but I'm not going to pass any color because I don't care about the color. So if it's by default some color, it's okay for me. So I have already a flat function. So now we have to be sure that we are calling this function. Okay, we're calling this function, this flat function. Sorry, on the show UI, I forgot to put here this other one. Flat, textured, and it's 3 options. Okay, so I can test it now if you want to see this flat and texture mode, but you will see that this flat mode is kind of well, you won't see much. Okay, so if I go here to rendering and I choose the flat mode, everything is flat and I didn't specify the color, so it's all dark. You see the skybox, by the way, which is bad. We shouldn't be seeing the skybox when you're rendering it in flat. It doesn't make any sense. So I'm going to also tackle that. I'm going to say that there's a function that renders the skybox, but only render the skybox if you are on the render mode different from flat, because otherwise I don't think it makes any sense to have the skybox. Okay, so we have simplified a lot our function. So now when we render the shadow maps, the problem is that I don't want to see if I call this, is going to call with the current render mode. So maybe I should change the render mode. So let's do this. I'm going to store the previous render mode. Pref is going to be render mode. Okay, I'm going to store it in this temp variable, call it pref. Then I'm going to change the render mode to flat. Okay, so it's going to be a render mode flat. Call render everything. And at the end of this, render mode has to go back again to pref. So this way I'm preserving the state of pref. I don't want to kill it. Okay, so now if I render this, it should be much faster because instead of rendering the house 3 times, it should be rendering only once. And you see, if I show you the shadow map, you can see it's the same, but I can tell you it's way faster. Okay, I can test it if you want on the other application on Inside, which, by the way, I closed it by mistake. So let's go here. Yep, and quick launch is this application. Go ahead, launch it. Okay, here we have it, and connect. Yeah, and then we capture 1 frame. Okay, and here you can see now the shadow map is way shorter. Before it was like half of the frame. Now it's way shorter because we realized about that bug, and we realized we're checking here. So it's always important. Let's go to the again here, and you can see here. If, by the way, if you want to zoom in here, you grab this box here and you drag it to here, and you can see here that if I move to the next draw call, every draw call is a different object. So I'm not rendering the same object twice. You can see that like there's a lot of, I mean, it's nice because here you realize, for instance, like the trash bin, it has 4 different draw calls, no, 5, 6 only for the trash. I mean, it's a horrible mesh, but anyway, 7 indeed, because it's also lit. Okay, cool. And so we have one improvement just because we were using this nice tool always. Okay, and you can see that this is the skybox, by the way. How the skybox is not appearing here, it's rendering from scratch. So super nice. I recommend you to spend a lot of time if you can with NVIDIA Insights graphics system. Just one tip: if you're going to download it, you have to download. I'm using the 2020.1.1 version. I put a link on the slides of the. I think it was the first slides of the framework. Because modern ones, I don't know why they don't work well with OpenGL, the version we are using in OpenGL. So use this version if you want to run it with the framework of the course. Okay. So let's close this. By the way, I didn't say, but when you're running it here, it says press Ctrl Z for HUD. So if you press Ctrl, I'm not using now the interface I showed you before. I'm in my application. If I press Ctrl Z, it opens this panel here, and you can click things here, and there's like a tool that you can use. No, it was here. Space. I don't have an idea. Yes, here, and you can capture it directly from your own tool. You can see here. You can visualize everything from the tool. You don't have to go to the other tool. Here is nice. You can see how it renders the car first, but it renders the car again with one light and render the car again with the other light. But it's hard to see. So there's an option to control what you want to see. I see I recall correctly. Maybe here, no, here, no, here. The wireframe, Control W. I don't know if that's what I wanted. Control W. No, it's a regular wireframe. No, it's there's a high show. There's an option which shows the object that is being rendered with single as out, single on board settings, switch to next normal. I don't know. There's one place where there is an option that you can control to say the object that is being rendered if you wanted to have it in this kind of thing. I did not remember which it was. Nothing here. I don't know what it is. This is go back, go to the timeline, and what's this? I don't know. Another important thing here, and I think it's nice, is that you will see something interesting when it's rendering. At the end of everything, when it has finished, you will see that suddenly you have the render calls also of the interface. You can see how it's rendering the interface. Because remember, the interface also rendered with OpenGL, so the GPU also, this function also catches it as something. And as you can see, the red channel, the green channel, the blue channel of in any moment. So it's nice because sometimes you want to check something. Also the depth buffer in any moment, and it's linearizing automatically, or the stencil buffer, but we are not using the stencil buffer. I see disable wireframe. This is what I wanted to tell you. So when we're rendering the car, let me show you again. Let's go when it's rendering the car here. You can see, let me show you. I'm going to disable the red wireframe. No, disable wireframe, yeah. So you can see how first it's going to render the car, then it's going to render the car with one light, then it's going to render the car with the other light, and then it's going to render the car with the other light, okay? And even if the fourth one, which, no, this is for the glasses, okay? So it's nice to see every single step of the rendering process here, okay? And you can catch a lot of errors if you do this. There's more options I don't have time to explain, but if you have some time, always feel free to play with these tools because, as I tell you, they are super, super, super useful. Okay, and now it crashed. I don't know why it's crashing because it doesn't close the window. Probably this is why they use saying the problem is that when something interrupts this application, another application yeah, it crashed. Yeah, it closed. Okay, cool. So we have the shadow map. It looks nice. We rendered on the screen. Everything was fine. So maybe it's time to do something. By the way, if you wanted to render the shadow map, let me go to the function, show shadow map here. I'm rendering full screen. Maybe you don't want to render it full screen. You want to make it tinier. So you can always call the GL viewport function. Okay, the GL viewport allows you to render to one specific area of the screen. So I don't know, you can say 3 pixels to the right, 100 pixels from the bottom, and I want to render it as a 2566 by 2566 texture. Okay, always when you modify the viewport, at the end you have to put it back, otherwise you will have problems. So I'm going to put it back here to window width and window height, but the window width and window height I don't have it here. So size equals core get window size. So it's going to be size X and size Y. So because we are reducing the size of the viewport to one specific area of the screen, when you call the to viewport, it's going to only show it in that small area. So you can see here, only in this small area, okay? And if you want every light map to be shown next to each other, maybe here we can have like plus X, X is going to start being 300, 310, and every time we render one, X is we're going to add 260 pixels, okay? So the first one is going to be in 300, the next is going to be 500, etc. Okay, so we can render more than one. The problem is we have a lot of them, is going to get out of the screen, but anyway. Cool. So we have shadow maps generated. We have to use them now. That's the tricky part. Okay, so when we render our frame, when we render our scene, we have to render with lights. Here, we should pass to the shader the shadow map in case there is a shadow map. So here, for every light, we have to tell the shader if it has a shadow map, and we have to pass the shadow map. Okay, so let's do that. First of all, we need the shader. Okay, so let's go to the shader first, and we construct the shader. So we were using this light FS here. So here we're going to go and say U shadow map. And remember that to use the shadow map, we're going to need also the projection matrix of the shadow map. So here we're going to have a mat4, which is called U shadow view prog, I think it's called. And we need a way to know if this is inside the shadow map or not. Sorry, if this object has a shadow map or not. By the way, because this is part of the information about the light, I'm going to put it here. So let's have a variable, I don't know, an int variable. Indeed, no, I'm going to have two variables because we also are going to need the shadow param. Some params, and it's going to be first is going to be is 0 if there's, or 1 if it has shadow map or not, and the second parameter is going to be the bias, and we can have more parameters. Remember, I like to pack them in one single uniform because it's a little bit faster, and it's more readable when you have separate different variables. But anyway, so here in my code, when I'm computing the illumination for the light, blah 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 blah, what I should be doing here is have a factor, like let's call it float shadow factor, that by default is going to be always 1, and the final illumination is going to be multiplied by this factor. Okay, so here I'm going to multiply by this factor. So by default, it's going to be always 1. It's not going to change anything, but if we want to have shadows, well, we better have a function to that. I don't want to put the shadow map, all the code inside here, because it's going to look a little bit ugly. So I'm going to make a function here, test shadow. We're going to call this function, we're going to pass the information we need, and this function is going to tell you if there is shadow or not, okay? So first, we're going to need to say which is the position where we want to test the shadow map, so the wall pos. And I think that's more or less enough. Well, we will see what we need. If we need something else, by default, it's going to return 1. So we will see. So this test shadow, we're going to call it from, I don't know, maybe here. Sorry, only we have to call it if there is a shadow map. So here, by the way, the wall position, it's in wall position. Okay. And shadow factor is going to be this. When do we need to call it? When the shadow parameter, I don't know how to call it, shadow param, the x is different than 0. If it's different than 0, there is a shadow map. So then call this function. Okay, I haven't modified almost anything. If I go here, I can say if this light has a shadow map, then it's going to need to pass these parameters. So shadow map, it was called shadow map texture, I think. Shadow map. The shadow map has to be the texture, so set texture. shadow map. I'm going to have pass the light shadow map to the shader, and I will also need to pass a slot. I usually put this in the last slot, in the 8th, or like one of the last ones, because I want to leave the first ones for materials and so. So I don't know, 8, 7. You have 16, so 8 is a good number. And as I said, we need to also pass all the shadow params. In this case, vector 2. I'm going to pass if it has a shadow map or not. Okay. I can put this outside, by the way. You will see why. Because I need to also to pass if there is a shadow map, even if there is not a shadow map. So here I have to say, if there is a shadow map, this has to be 1. Otherwise, it has to be 0. And the second value has to be the shadow bias. So here you will see the shadow map bias. Okay, if it doesn't have a shadow map, we would send a number. It's okay. So we set the shadow map, and obviously we have to set also the view projection of the shadow map. Shadow, I don't know, view proc. Maybe I have to change the name because I think in the slides it's kind of different. Shadow view proc. Okay, so there is a shadow map. We pass 1, and we enter this function, and we pass this to it. There is not a shadow map. Nothing to do here. Cool. So more or less, all my job here from the C++ is done. So time to go to this function here. I can execute, by the way, always. It goes well to execute to see everything is going well. And bim bam boom. It crashed. Ooh. It crashed because shadow factor. It says it implicit from vector 3 to vector 4. What? I put vector 4? No, vector 3, sorry. It's a vector 3 world boss. Because world boss is a vector 3. Yeah, it's a vector 3. Sorry. And here we have it. It works. No shadows, because the shader is not doing anything. But we are very close. Here is the function that should compute the shadow map. So let's do the final step, which is, as you can see, there's many things here I didn't put. I didn't put the color mask. This is an optimization, but more or less everything is very similar. Here you can see how to set up the camera. I already did that for this light. How to set up the things and upload it to the shadow, blah, blah, blah. Nothing interesting here. The bias, blah, blah. But here is the model of the corridor, which is code. So let's go here and put here. So let's check again to see. First, the matrix is called shadow view proc. Okay, perfect. I put the right name. And it's going to be divided by pos. I put world pos here. Let's call it pos and let's save us some changes. It's going to compute the UV of the shadow map, and then it's going to go to shadow bias. I don't call it shadow bias, I call it shadow params dot y. The rest is okay. Shadow map. It's not called shadow map, it's U shadow map. I don't know why I put it here. And it's going to compare, blah, blah, blah. Otherwise, shadow factor is going to return 0. Shadow factor, I don't think I have to, but anyway, return shadow factor. I don't know why I did that way, but it's okay. So more or less, I think everything is right here. I don't see anything strange. It's not such a big code. So let's test to see what happens. Anything can happen here. Let's see what we have here. We have something that looks like a shadow behind the object. And if we go to the spot and we move it around, let's see when the light moves, up, down. But there's still some strange things. Maybe we'll have to explore later. No, it looks nice. Oh, well, sorry, the light is inside the car. There's something weird. Yep. There's something weird. There shouldn't be any shadow here. So, let me go to the spotlight. If I remove the spotlight, this is interesting. Look, behind the spotlight, if I disable the spotlight, when it's enabled, there's darker, and if I remove it, it's lighter. It's like the shadow map, this light is erasing light due to the shadow map. Okay. I never have experienced this bug, so I guess it may be that the texture is not cleared properly or something like that. Maybe it's a good case to use inside. but I'm not going to be able to see anything inside. So let me check again all the parameters. I want to be sure I'm not missing anything silly. So the bias, let's play around a little bit with the shadow. When something doesn't work properly, it's good to construct what I usually call some intuition. And to do that, let's go. What happens if I modify the component? I'm also going to show meanwhile the shadow map here. Oops. Well, anyway, it's. I want to move it here because otherwise I'm not going to be able to see. So in the shadow map function I was doing before, the one that renders the shadow map, I did an error here, which is when it was shown the book shadow maps. The book shadow, yeah, here. I was adding the number. Oh no, here 300. Sorry, I shouldn't have put 300 here. Okay. So now I can see the shadow maps a little bit better because otherwise. Okay, rendering, show shadow map. Here we have it, and I go to the entities spot. So it works fine. Ah, yes. Yes, I know what it is. Okay, sorry, I forgot one line of code. It's in the slides, but it's in the next slide. I should have put it in the first slide. The thing is that if it's inside the cone, it works perfectly. As you can see, these shadows work super well. There is no problem here. The problem is it's outside. When it's outside, I'm not controlling that case. When a pixel falls outside of the shadow map, outside of the texture, I'm just reading the texture. Because I'm reading the texture outside, it's going to read the last value. When you read the texture outside, if it doesn't have tiling, it's going to read the last pixel in the border. So it's applying that value outside as the shadow factor, which doesn't make any sense. So in my case, it's as easy to fix as saying, hey, when I'm going to read from the shadow map, if this value is outside of the range 0 to 1, it's outside of the shadow map. So you cannot know if there is a shadow map here. So here I should say something more on the line of here, this line here. I forgot to put this one, which says if the shadow map is outside, okay, the shadow UV is outside, then you can decide if you want to put 1 or 0. I'm going to put 0 because it's a cone, and if it's a cone shadow, it doesn't make any sense that it's illuminated. So now it should work. Ta-da! And now we have the shadow map. Also, something strange is that the shadow map is killing. Sorry, the way I use the test shadow is wrong. Let me show you where I put the test shadow. So I put a shadow factor. I multiply by the color, and the shadow factor, if it has a shadow, yes, you can see I'm making an error. Look, light has the ambient light, but if this shadow factor is 0, I'm multiplying this by the shadow factor, which means that I'm killing the ambient light. That's why behind the light there was darker. So what I should do is only apply this in the case that it's inside. So sorry, I should have applied here per light. I was applying it for the whole final render, and that's it with this beautiful factor. If everything goes well, okay, we have something that looks, but still the cone of the famous cone of the spotlight is gone. I think the shadow map size it's wrong. Yes. I think I have a theory. Let me show you what I think what's happening. So I have the cone of the light should be like this, but I'm seeing that when I render the shadow map is only like this, something like this, and it's cutting outside. And I think that the only reason could be that the angle here is not the same angle as here. So this is narrower, and because it's narrower. And so I have the impression that I did something wrong with the angles. Probably in a place where the angle should be doubled, I put not doubled. So I know how to fix it very fast now is when I compute in the camera for the shadow maps. Here, this fob has to be twice as big. I'm going to multiply it by 2, but I don't know. I mean, I thought that the angle was right before when we check it. Anyway, now it will look nice. So you can see now we have the cone and the shadow matches. Okay, so if I go here to the cone and I make it smaller, so here like this, it works well. Okay, Anyway, this happens a lot. I mean, if you don't have coherence on your values, it can happen that some values don't have the right sizes and stuff like that. Okay, anyway, we have now a shadow map for one of the lights, okay, for the spotlights. And you can see it looks super nice when you put it, like, I don't know, inside behind the car and everything, okay? Still, the render time is growing, obviously. You can see here that it's doing 101 render calls. If I go to the other render mode, the texture, you can see it's only 32 render calls. But then just because we have lights, it keeps increasing and increasing. And I can tell you there will be a moment where it will be a lot of much more time. By the way, this time is like stuck here in this number. That's weird. Okay. So now you have a way to implement shadows for spotlights and for directionals. Your work is to do the directional light. You have all the code on the slides and to put everything together. Okay, some final comments. What happens if I want to render shadow mask for we're using it in multipass, and in multipass it's easy. For every light you just keep applying different shadow map. But what if I want to use single pass, so all the shadow maps at the same time? Well, that's tricky. I mean, if you want to do that, that implies that you have to have a lot of textures on the shadow map, sorry, on the shader. You can have like upload 4 different shadow maps to the GPU and use it on the shader. You can decide which ones to use. That's an option. But there's another option I recommend you, which is much more simpler. I implemented super easily, which is you only have one shadow map, but that shadow map has all the shadow maps inside, which is called the shadow atlas I explained the other day. So the idea is that you create one shadow map, okay, but when you have to render the shadow map, instead of using the full screen, by default, every time you do the what is it here, the enable the FBO, if you go to the function here, you will see I set up the viewport to the max size of this texture. Okay, so here if you can specify something like no, I want to do viewport of smaller area, like from 0 to, I don't know, like this, then you will be rendering to only that part of the texture. So in this case, it would be from 0, which is here, to half of it, so it's going to render here, okay? So you will have your shadow map here. Next texture, so next shadow map that you have to generate, you can move the viewport to here and render it here, and next one to here and render it here, and etc. Okay, you do that in one texture, you can have like 4, or maybe you want to have 16. I don't know. Also, this texture doesn't have to be square. This texture could be, if you want, could be rectangular. So you can have like 8, something like that. You wish. I mean, you decide. Okay. So this part is super easy. It's just changing one line. Ultra easy. The other part is how do you know from the shader which is your part. So what I do is I store these numbers in the light shadow. So there's a parameter called region, like this, and it's a vector 4 where you specify which is the area of this shadow map, but normalize it because your UVs has to be normalized. So something like this, like divided by the width and divided by the height of the texture. Okay, then these parameters, the region, you send it to the shadow. To the shader. I was having the same mistake. And inside the shader, you take these parameters and you modify the UVs. So that when you have this UV here on the function test shadow here, before you go here and say, wait, this UV is supposing that the shadow map goes from one side of the texture to the other side, but you have to adapt it to this area. So you have to do a scale. So instead of going from 0 to 1, if everyone it's half of the texture, it's 0 to 0.5, and then if it's not doesn't start at 0, it starts at 0.5, then you add the offset. Okay, it's very simple. I recommend you to check the function remap that I think it's explained in some of the slides, the classical function where you have a value that goes from one range to another and you want to adapt it to another range, but it's adding and multiplying, so it's supposed to be super simple. Okay, then that way you have one shadow map, which is much easier because then you don't have to be binding different textures to the GPU, which takes time to bind different textures, and also it's much easier for the code. The only problem is that you have a limitation. You have a maximum number of shadow maps simultaneously, which by the way is good because Usually in engines you don't want to have thousands of shadow maps. Doesn't make any sense. And also you can't forget about the problem I said before, that why if I remove a light I have to free the area, the light memory. Like imagine that I have a scene with lots of lights that have shadows, but I'm usually only seeing 2 or 3 at the same time. I will have still memory allocated for the other ones, which I'm not using. So it's always nice that we reuse the same shadow map for different lights. So to do that, putting the shadow atlas inside the render is much easier. Anyway, if you manage to do it, I give 0.5 points for that. Okay, so good to try. And I will tell you that it will make rendering the part of the single pass much simpler, because you only have to pass the array of all the areas for every shadow map. Anyway, so that's all for today. I mean, you can see, you understand the mathematics and the GPU. Things are not so complex, okay? So this is going to be the big bulk of the first assignment. So the first assignment has to have illumination, and you have to have shadow maps, and that's it. The time for the delivery is going to be, so you have this week until next week to finish this. So it's going to be probably on Wednesday. No, on Tuesday. Tuesday of next week. Okay, so you have plenty of time to 1 week to code the shadow maps, and then next week I'm going to, after that I'm going to start a new topic. So you better have everything ready. Okay, cool. Any doubts? Go to the Discord. You are not using the Discord. I'm pissed off about that. Use more the Discord. Show you what you're doing. Show the problems you're facing. Other people can have the same problems, so it's nice to start a conversation. Okay, and that's it. As I said, sorry I couldn't be for the class on this Wednesday, but I'll see you next week. Bye.